Here's the lesson for Friday, September 10th. It's R7, day 3, and this is over complex fractions. So here's our first example. We are adding on the top a whole number and a fraction, and on the bottom a whole number and a fraction. So we've got these smaller fractions within this larger fraction, and we have to get rid of those smaller fractions. And you can see that I've listed the steps for you to accomplish this. So what you want to do is you want to find the least common multiple for the denominators of each fraction. So let's take a look at what our denominators are in this case. On the top, the fraction has a denominator of x, and on the bottom, it also happens to have a denominator of x. So this is going to be a simpler problem because the denominators are the same. So that's what we're going to multiply by, because multiplication will undo that division. But we have 4 terms. We have 2 on the top, a 1 and a 1 over x. We have 2 on the bottom, a 1 and a 1 over x. And all 4 of those terms have to be treated the same, so they all have to get multiplied by x. So I'm going to group my fraction, and I'm going to put an x on the top and an x on the bottom. And I'm just going to remind myself that I'm going to distribute that x, top and bottom, to all 4 terms because they all have to get treated the same. So now I'm just going to go back and do that multiplication. X times 1 on the top is just going to give me an x. X times 1 over x, those are reciprocals. And when we multiply reciprocals, we always get 1 as our answer. The other way you could think of it is you're multiplying by x and dividing by x, so we can just cancel those, and we'll just get a 1 there. So I'll bring over my plus sign and my 1. And on the bottom, x times 1 again will give me x. I have a minus sign on the bottom. And then again, I have reciprocals, or I can think of it as multiplying by x and dividing by x. Those cancel, and I get a 1 there. And now I've gotten rid of those smaller fractions within the larger fraction, so I've simplified my expression, and I no longer have what's considered a complex fraction, and I'm done. So for my next example, you can see that I've got this larger fraction, and in the denominator of that fraction, I have 2 smaller fractions. So I need to, once again, look at the denominators of the fractions that I have. And in this case, it looks like I have an R1 and an R2. So I'm going to go ahead and just put a box around those. Those are what I'm going to need to multiply by, because those are the expressions or the terms that I'm dividing by. I have 3 terms altogether. I have a 1 on the top, a 1 over R1, and a 1 over R2 on the bottom. All 3 of those terms have to get multiplied by both R1 and R2, because now my least common denominator isn't the same, or the denominators, I should say, aren't the same. I have an R1 and an R2. Those are 2 different variables. So I have to multiply the top and the bottom by R1 and R2. And I'm going to show this in a slightly different way than I did in the last example. So on the top, I'm going to put times R1, R2, and then I'm going to come down at the bottom and I'm going to put an R1 and an R2, and notice I'm putting that with the numerator because I'm multiplying there, okay? And the same thing for this other fraction. I'm going to multiply by R1, R2, all right? So what's the fallout of that? Well, on the top, 1 times R1, R2 is just going to be R1, R2. And on the bottom, I have an R1 on the bottom and an R1 that I'm multiplying by, so those R1s I can cancel. I cannot cancel the R2 there. R2 times 1 is going to give me R2. Then I come to my plus sign. I'm going to bring that over. Now I'm going to look at the other fraction. I have an R2 on the bottom and an R2 that I'm multiplying by. So again, I can cancel the multiplication and the division, and now I just have R1 times 1, which of course will just give me R1. And so now this is my final answer because I no longer have a fraction within a fraction, and I am done. Okay, for this next example, you can see that we have 3 fractions. We have 2 on the top and we have 1 on the bottom. And if I look at the different denominators there, I can see that I have a 2 as a denominator, I have an x as a denominator, and I have a 4 as a denominator. And my common denominator has to account for all of those. Now the 2 goes into 4, so I could just use the 4 and the x, but it's going to be a little bit easier to see the math if I just use all 3 of them. So what I'm going to do is similar to what I did in example 2, where I'm going to show that multiplication individually for each fraction rather than doing the distribution like I did in the first example. So my first fraction on the top is a 1/2. I'm going to multiply by 2, by 4, and by x. And I'm going to do the same thing with the 3 over x. It's going to get multiplied by 2, by 4, and by x. And on the bottom, I'm going to multiply by 2, by 4, and by x. And note, I'm putting that multiplication up in the numerator where it belongs, okay? So now I'm going to cancel anything that I can cancel, top and bottom, and then I'm going to simplify. So this first fraction, the 1/2, I can cancel the 2's top and bottom. What's left? 4x times the numerator, which is a 1. So that's going to give me a 4x. Then I come to my plus sign. I'm going to recopy that. Now I go to the next fraction, which has a denominator of x, and I also have a multiplication by x. So the x of multiplication and the x in the denominator, those cancel. And now I have 3 times 2 times 4 left. Well, 3 times 2 is 6, and 6 times 4 is 24. So I'm going to jot that down. Now I'm going to go to the bottom. I've got a 4 on the bottom, and I'm also have a multiplication by 4, so I can cancel those. What's left? Now I have x plus 3 being multiplied by the 2 and the x that did not cancel, so I'm going to write that. And now if I take a look on the top, I should factor out that common factor on the top. 4 and 24 are both divisible by 4, aren't they? So that means that top and bottom, if I write them both in factored form, if I factor out that 4, I have 4 parenthesis x plus 6 over, and now so you can see easier what's happening, that 2x, I'm going to put it in the front, and then the parenthesis x plus 3. And then if I look top and bottom, the 4 over 2, I can reduce that because 4 is divisible by 2. So the 4 is going to become a 2, and the 2 is going to cancel. So I could write my final answer as 2 parenthesis x plus 6 divided by x times x plus 3. And this would be my final answer in simplified form. So I'm going to do one more example, and this is actually one of the problems right out of the book. So if I look at the fractions that I have, the denominator of the fraction on the top looks to me like it is an x plus 1, and the denominator of the fraction on the bottom is just an x. I have to undo that division, and I'm going to have to use both of those denominators. And all 4 of my terms are going to have to get multiplied by x and x plus 1. So what does that look like? Well, I can write it out, x times x plus 1. That's going to get multiplied by the number 1. It's also going to do, I'm going to multiply x plus 1 times x times that minus x on the top. Then I'm going to come to the bottom. That 2 has to get multiplied by an x and an x plus 1. And the x minus 1 over x also has to get multiplied by x plus 1 times x. Now, before I actually do any of that multiplication, I'm going to cancel anything I can cancel. The very first term, that 1, there's nothing to cancel because I don't have a fraction there. So I'm just going to do 1 times x plus 1. And it looks like I dropped my 1 there. Let me fix that. And so I come to a minus sign next. And now this next expression, I do have a fraction. And on the bottom, I have x plus 1, and I'm multiplying by x plus 1. So I can cancel those. And then I'm left with an x times an x, and that's going to be x squared. Then I'm going to go to the bottom. I'm going to do the same thing. I'm going to have 2 times x plus 1. So I'm going to have a 2x times x plus 1. And then I have a minus sign, so I'm going to bring that minus sign over. And then again, I come to a fraction where I can cancel an x top and bottom. And so now I'm going to have x minus 1 times x plus 1. And I'm going to put that in another set of grouping symbols because of that minus sign in front of it. And now I'm going to do a little bit of multiplying and cleaning up. So on the top, I'm going to distribute that x to both terms in the parentheses, and I'll get x squared plus x, and then I have a minus x squared, so that's the top. And then on the bottom, if I distribute that 2x to the parentheses, I'm going to get 2x squared, I'm going to get plus 2x. And then I'm going to bring the minus sign down, and if I FOIL there, I'll actually get x squared minus 1. Now I'm going to need to do one more step there because I got to distribute. So the top isn't going to change. It's going to stay x squared plus x. Oh, actually, let me fix that right now. Why don't we cancel there? So let's go ahead and cancel the x squared minus x squared. So the top is going to simplify nicely to just x. And then the bottom, I'm going to have 2x squared plus 2x minus x squared plus 1. And then one more step to clean this up. The top is going to be x, and the bottom is going to be, let's see, 2x squared minus x squared will just give me an x squared. And then I have a plus 2x, and then I have a plus 1. And that is my final answer. Nothing else is going to simplify or cancel there. So those examples should be enough for you guys to do 3 problems. I'm not going to give you a lot of problems to do. I'm just going to give you 3 to try, and then we'll talk about this in class on Tuesday. So the homework is on page 72. I would like you to do problems 73, 74, and 75, and we will talk about it on Tuesday. Have a good weekend.